Enterprise Java Beans, or EJB, are a core technology in Java EE. They are server-side components that encapsulate business logic and data persistence. EJBs provide a robust framework for developing and deploying enterprise applications. They offer features such as transaction management, security, and concurrency, which simplifies the development process. EJBs are essential for building scalable, secure, and maintainable enterprise applications. They promote modularity by separating business logic from presentation and data access layers. This modularity enhances reusability and simplifies application maintenance. Session beans are the most common type of EJB. They encapsulate business logic and workflow, acting as intermediaries between clients and data sources. Session beans can be stateful, maintaining conversational state with the client, or stateless, treating each client interaction independently. Stateful session beans are useful for managing user sessions, shopping carts, and other scenarios requiring session persistence. Stateless session beans are suitable for operations that don't require conversational state, such as data retrieval or calculations. Session beans offer a flexible and powerful mechanism for handling business processes. They provide a centralized location for implementing business rules, ensuring consistency and maintainability. Their ability to manage state, either stateful or stateless, allows for diverse application scenarios. Entity beans represent persistent data stored in a database. They provide an object-oriented view of data, allowing developers to interact with data using Java objects. Entity beans simplify data access and manipulation, abstracting away the complexities of database interactions. Entity beans can be container managed, where the EJB container handles persistence, or bean managed, where the bean itself manages persistence. Container managed persistence offers simplicity and ease of development, while bean managed persistence provides greater flexibility and control. Entity beans are crucial for modeling and managing data in enterprise applications. They provide a structured and object-oriented approach to data persistence, enhancing data integrity and simplifying data access. Their ability to handle complex relationships between data entities makes them suitable for modeling intricate business domains. Message-driven beans, or MDBs, process asynchronous messages from messaging systems like JMS, Java Message Service. They enable loosely coupled communication between application components, enhancing flexibility and scalability. MDBs act as message consumers, listening to specific message queues or topics. MDBs are event-driven, meaning they are triggered by the arrival of messages. They are stateless and designed to handle messages concurrently. This asynchronous nature makes them ideal for tasks that can be processed independently without blocking the sender. Message-driven beans are essential for building responsive and scalable enterprise applications. They facilitate asynchronous communication, enabling decoupled and efficient message processing. Their ability to handle high volumes of messages concurrently makes them suitable for event-driven architectures and integration with external systems. Transaction management is a critical aspect of enterprise applications, ensuring data consistency and integrity. EJBs provide comprehensive support for transaction management, allowing developers to define transaction boundaries and control transaction behavior. EJB containers manage transactions, ensuring that operations within a transaction are either committed or rolled back atomically. This guarantees that data remains consistent, even in the face of failures. Developers can specify transaction attributes, such as transaction isolation level and propagation behavior. Transaction management in EJBs simplifies the development of reliable and robust applications. It ensures data integrity, preventing data corruption and inconsistencies. The ability to define transaction boundaries and control transaction behavior gives developers fine-grained control over data operations. Security is paramount in enterprise applications, protecting sensitive data and resources. EJBs integrate seamlessly with Java EE security mechanisms, providing a robust security framework. They support declarative security, allowing developers to define security constraints using annotations or deployment descriptors. EJB containers enforce security policies, controlling access to EJB methods based on user roles and permissions. This ensures that only authorized users can access sensitive data or perform privileged operations. Security roles and permissions can be defined at various levels, providing granular control over access. Security features in EJBs are essential for building secure enterprise applications. They provide a robust framework for authentication, authorization, and access control. The declarative security model simplifies security management, allowing developers to focus on business logic rather than low-level security details. Scalability and performance are critical requirements for enterprise applications, handling increasing workloads and user demands. EJBs are designed to support scalability, allowing applications to handle growing user bases and data volumes. EJB containers provide features such as pooling, clustering, and load balancing, optimizing resource utilization and enhancing performance. Pooling allows containers to reuse EJB instances, reducing object creation overhead. Clustering enables the distribution of workload across multiple servers, enhancing scalability. Scalability and performance features in EJBs are essential for meeting the demands of modern enterprise applications. They enable applications to handle high volumes of users and data, ensuring responsiveness and efficient resource utilization. The ability to scale horizontally through clustering provides flexibility and resilience in the face of growing demands. Enterprise beans have evolved significantly since their introduction in EJB 1.0. EJB 2.0 introduced significant improvements, simplifying the development model and enhancing container-managed persistence. EJB 3.0 further simplified the programming model, embracing annotations and reducing boilerplate code. Modern EJB architectures leverage the advancements in EJB 3.x and beyond, focusing on ease of development and integration with lightweight frameworks. The use of annotations, dependency injection, and POJO-based programming models has streamlined EJB development, making it more aligned with modern software development practices. The evolution of enterprise beans has addressed the complexities of earlier versions, making them more accessible and developer-friendly. The shift towards lightweight frameworks and POJO-based programming models has modernized EJB development, aligning it with contemporary enterprise application architectures. Enterprise beans remain relevant in the modern enterprise application landscape, providing a robust framework for building scalable and secure applications. They offer comprehensive features for transaction management, security, and concurrency, simplifying the development of complex enterprise systems. However, alternative technologies such as Spring Framework and Jakarta EE, formerly Java EE, have emerged, offering lightweight and flexible approaches to enterprise application development. These alternatives emphasize simplicity, modularity, and integration with modern web frameworks. While enterprise beans retain their relevance for specific use cases, particularly in legacy systems and applications requiring robust transaction management, developers now have a wider range of choices for building modern enterprise applications. The choice between EJB and alternatives depends on factors such as project requirements, existing infrastructure, and developer expertise. Enterprise beans are a fundamental technology in Java EE, providing a robust framework for building scalable, secure, and maintainable enterprise applications. They encapsulate business logic, data persistence, and asynchronous communication, simplifying the development process and promoting modularity. Session beans handle business workflows, entity beans model persistent data, and message-driven beans process asynchronous messages. EJB containers provide comprehensive support for transaction management, security, and concurrency, ensuring data integrity and application reliability. While enterprise beans have evolved to embrace modern software development practices, alternative technologies have emerged, offering lightweight and flexible approaches. The choice between EJB and alternatives depends on project-specific requirements and architectural considerations. Nonetheless, enterprise beans continue to play a significant role in the development of robust and scalable enterprise applications, providing a solid foundation for building mission-critical systems.